Today we're going to be talking about simplifying radicals. Let's go ahead and get started with that by taking a look at a few vocabulary terms. So the vocabulary terms that we need to know here are radical. That's the symbol that is used to denote the square root or cube root of numbers of an algebraic expression or monomial. And then a radicand is a number of algebraic expressions, monomials, inside the radical symbol. Now let's take a look at some more examples. So now we're going to review some perfect squares. So the first one we have there is the square root of 25. So what is the square root of 25? It is 5. And we know that because 5 times 5 equals 25. So perfect square. The next one is 64. So what is the square root of 64? It's 8 because 8 times 8 is equal to 64. And the last one says what is the square root of 196? And we know that is 14 because 14 times 14 equals 196. Now let's take a look at some more information. A simplified radical has 1. No perfect squares under the radical. 2. Is fully simplified. And 3. No fractions in the radicand. Now let's take a look at the steps on how to simplify a radical. So how to simplify a square root? Factor the number until there are only prime numbers left. We're going to take out groups of 2 for a square root and then multiply any coefficients together. So now let's take a look at some examples. So here we are at example A, and it has the square root of 18. So we're going to simplify the square root of 18 by breaking it down into perfect squares and then dragging out the numbers that we have pairs of. So the first step I'm going to do is get rid of the 18, and I'm going to break that down into 9 and 2, because 9 times 2 equals 18. Now 2 is a perfect square, so I can go no further than that, but 9 can be simplified to 3 times 3. So now I've gone as far as I can. I have 3, 3, and 2. They can no longer be broken down. So now I have to start circling my groups. So it looks like I have a pair of 3's here, and I have a 2 all by itself. So the 2 is going to stay underneath the radical. So I'm going to have the square root of 2 here. And the 3's are going to come on the outside. So my simplified answer is 3 times the square root of 2. So this is my final answer. This is as far as I can go. Now let's take a look at example B. So here in example B, I've got the square root of 108. So I'm going to put 108 up here at the top, and then I'm going to look for perfect squares that I can drag out of it. Now, if you're thinking to yourself, I'm not really sure what perfect squares I can use because I'm not really sure what times what is going to give me 108, you could always try and take out things that you know, prime numbers, for example. In this case, I've got 108, and I can see that it's an even number. So if I can't think of any perfect squares to remove, I know I can remove 2. Because if I take a 2 out of 108, that's going to leave me with, again, a smaller number, but I've also got my prime number. So if I do 108 divided by 2, that's going to give me 54. So then again, if I can't think of any perfect squares that would come out of 54, I could say, all right, I could take out another 2 because it's an even number. So again, I'm going to take out a 2. 54 divided by 2 is going to leave me with 27. And then I might be getting somewhere that I know. So then I know that 27 is going to be 9 times 3. So I could do 9 times 3 for 27. And now I see that I have a perfect square that I know, and 9 and 9 is going to be 3 and 3. So now we're going to go about circling numbers that we see that are in pairs, of course. So we've got a couple of 2's here that can be a pair, and we've got a couple of 3's here that can be a pair. So we're going to take those to the outside. So on the outside, we're going to have 2 times 3. And on the inside, we're left with just one little 3 all by itself. So it's going to stay on the inside of my radical. So 2 times 3 is going to be 6. So my final answer is 6 times the square root of 3. Now let's take a look at example C. So here we are at example 3, and I've got the square root of 48. So I'm going to write the square root of 48 at the top of my tree here, and then I can determine either way I wanted to simplify this. I can either take out perfect squares, or I can be like, I don't know any perfect squares, but it's an even number, so I can divide by 2. I'm going to go perfect squares this route because I know 16 times 3 is going to give me 48. So if I do 16 times 3, I know that I've got 3. That's a prime number already. Then I can do my 16, and I know that is a perfect square of 4 times 4. So I know now that I've got only prime numbers. I can start by circling my pairs. So I've got a pair of 4's. I don't have anything to go with the 3. So my final answer for this one is going to be a 4 on the outside and it times the square root of 3 on the inside. Now let's take a look at the final example. So here we are at the final example, example number 4, and it tells me the square root of 99. So again, I'm going to put the square root of 99 at the top of my tree, and then I'm going to either look for, well, this isn't an even number, so I can't divide by 2, so I'm going to have to go with my perfect pairs, or I could divide by 3 if I wasn't really sure, because this isn't divisible by 3, or perfect squares, not perfect pairs from earlier. So I'm going to go with doing my perfect square. So in this case, I know that 9 times 11 would give me 99. So I'm going to put 9 on this side, 11 on this side. 11 is prime. I can't go any further with that. But I can take my 9 and make 3 and 3. So now I can take my numbers, start circling pairs. So 3 and 3 go together. So I have 3 on the outside with the square root of 11 on the inside. And that's as far as I can go. So that brings us to the end of this example. It also brings us to the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub. And we will catch you in the next one.